Okay, so this is our last, can you believe it? Our last math lesson after 3 years. I've recorded this now 8 times, messed up different spots, sometimes 5 seconds in, sometimes 15 minutes in. And sometimes when I'm done, I realize I want to do it over again. So here we go. So we will be able to determine how many unique combinations there are given a scenario. Okay, so combinations. We have to understand what this is. So here's the Googled definition: adjoining or merging. So a merging of different parts, in which the component element. So in which the elements are distinct. So it's easier just to actually show you what it is. So there's a row of 3 chairs. So we got 3 chairs. So Brian, Christian, Quinn, and Solomon run to the chairs with an S, because no one wants to stand. So they're all basically sitting down like real fast, right? Trying to get the chairs. How many unique combinations of people can be sitting? Now remember, there are only 3 chairs, but there are 4 people. So the first the first thing we should do is let's list all the permutations, all the possible. Let's pretend there were 4 chairs. We could do Brian, Christian, Quinn, Solomon. We could do Brian, Christian, Solomon, Quinn. Brian, Quinn, Christian, Solomon. Brian, Quinn, Solomon, Christian. Brian, Solomon, Christian, Quinn. Brian, Solomon, Quinn, Christian. And so on and so forth. This one we start with Christian. This one we start with Quinn. This one we start with Solomon. Now, these are all the possible permutations if we had 4 chairs available. Right? Chair 1, chair 2, chair 3, chair 4. So there are a total of, let's make that a little nicer. Not too much nicer, but 6 here, 6 permutations here, 6 permutations here, 6 permutations here. So the first thing we have to do is find the total number of permutations if there was a chair for each person. Chair for each person, chair for each. So that's 4 chairs. Next thing you got to do is, well, we don't really care about the 4 chair scenarios. So like in this one, it says Brian, Christian, Quinn. In this one, Sal never made it, right? In this one, Quinn never made it. Solomon never made it. Christian never made it. Quinn never made it. Christian never made it. So basically, we get rid of this last turn or this last chair that we put in. Thankfully for us, we still end up with 24 permutations of 3 instead of 4 this time. So we're getting closer. Now, when it comes to combinations means there are like a unique set of people. We didn't say they had to sit in this order. We just want to know how many unique combinations of people can be sitting. So, for instance, we have Brian, Christian, Quinn. So we're like, cool. Let's make that a check. Brian, let's look for another Brian, Christian, Quinn. Brian, Christian, Quinn. They're in a different order, but it's the same combination of people. So, Brian, Christian, Quinn. Brian, Christian, Quinn. Brian, Christian, Quinn. Brian, Christian, Quinn. Same combinations of people. So, let's look for the next one. Brian, Christian, Solomon. Let's put the next. Brian, Christian, Solomon. Brian, Christian, Solomon. Different order. Same combination of people. Brian, Christian, Solomon. Brian, Christian, Solomon. That's interesting. Brian, Christian. Nope. Because Quinn has to be part of this. Brian, Christian, Solomon. Brian, Christian, Brian, Christian, Solomon. There he is. Wait. What are we looking for? Brian, Christian, Solomon. So that last one was wrong. Brian, Christian, Solomon. Okay. So now we have Brian, Quinn, Solomon. I guess we can put a question mark. Brian, Quinn, Solomon. 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 Okay, looks like we have a Christian, Quinn, Solomon. Let's quickly. Christian, Quinn, Solomon. Christian, Quinn, Solomon. Christian, Quinn, Solomon. Christian, Quinn, yeah. Christian, Quinn, Solomon. Christian, Quinn, Solomon. Okay. So what we're trying to do here... Okay, basically I marked off all the repeats of the same combinations. So for all these checks, there's basically only one, right? There's a Brian, Christian, Quinn. So we have 4 different types of combinations. We have checks, we have X's, we have question marks, and we have squigglies. We only have 4 unique combinations. It's assumed that when we say a combination in this way, at least in math, that they're unique. So, like Brian, Christian, Quinn counts, any order of those 3 counts as one combination. The question is, how can we do this a little faster? Because this way, imagine if you had like 10 people or like 30 people trying to fit into like 4 chairs or something. This kind of gets crazy. So the first thing I would do, remember the first step where we basically listed out all the combinations if they all had a chair. So we have 4 people. If they all had a chair, it'd be 4 factorial. So this would be 4 times 3 times 2 times 1. 4 times 3 is 12 times 2 times 1. 12 times 2 is 24 times 1 is 24. So these are the, I guess, total permutations. If, let's say, if the chairs equal the same amount of people, right? So we got that. Now, remember that we have to take away that last step. So remember what it's 4, 3, 2, 1. We have to get rid of that 1 like we did in the previous lesson. So that's 4 times 3 times 2 times 1 is again over 1. So 4 times 3 times 2 is 24. So this means we have 24 permutations of 3. Perms of 3 people. Now, remember where we found out that each set of 3 can be repeated 6 times. Each set of 3 BCQ, for instance, was repeated 6 times. 1, 2, 3, 4, 5, 6 times. The question is, how do we get that 6 times if we don't know it? Because we don't want to draw it out each time. Remember, we just say 3 factorial is how many times 3 things can be arranged. So 3 times 2 times 1. This is 6. So there's 6 possible ways the same thing can be rearranged. So we'll say this is 6 permutations per unique combo. So we'll say combinations. or we'll say combination. So for this combination, it can show up 6 different ways. So we take the total number, which is 24, because there's 24 total sets of 3, and then we just divide by the 6, because there's 6 versions of the same thing for each one. So we do 24 divided by 6, and we get 4 unique combinations. Now you might ask, why did I do this first step? Because there's 24 of them. Even when I cut off the first step, there are 24 of them. That's not always the case. They can actually get pretty complicated, where there are certain ones that it'll say BCS and it may say BCS later. So we don't. But for now, just stay with me, okay? Just follow my step.